Today we will learn how to differentiate between a weak acid and a strong acid, know what a buffer is, and how to calibrate a pH meter, as well as use it to determine the pH of an unknown solution.
When a strong acid like hydrochloric acid is dissolved in water, it is completely ionized, which means it's separated into hydrogen and chloride ions. When a weak acid like acetic acid is dissolved in water, it is slightly ionized, which means there are more molecules of acetic acid and a few of hydrogen ions and acetate ions are present.
Here are the dissociation equations for the strong acid HCl and the weak acid CH3COOH, acetic acid.
So what is a buffer solution? A buffer solution is a solution where the pH is resistant to small additions of a strong acid or a strong base. This can be composed of a weak base and a conjugate acid. Buffers are usually used to regulate functions that can only happen at certain pH levels.
Before calibrating the pH meter, my colleague here, Logan, washes it off with distilled water. We use a 2-point calibration method to calibrate the pH meter. First, after cleaning the meter, we put it in a pH 7 buffer solution which has a green tint to it. Using the LabQuest monitor, Logan calibrates the pH meter by typing in 7.0, which is the pH of the buffer that the meter is currently in. The second calibration point is a pH 4 solution, which has a green tint to it. When clicking Calibrate Now on the pH meter LabQuest monitor, Logan types 4.0 for the second point. Here, I perform the 2-point calibration method with a better view of the screen, so I click Calibrate Now and then wait for the live voltage to stabilize and then type in 7.0 as it's in the pH 7 buffer. Between point 1 and point 2 of the calibration method, it's important to clean the pH meter before putting it in the pH 4 buffer solution. Then, I wait for the live voltage here to stabilize and type in 4.0 as it's a pH 4 buffer solution. Then, the meter should be calibrated. 3.97 is very close to pH 4. Here, Sarah performs the calibration of the pH meter. It is important to calibrate the meter so that you can get a somewhat approximate reading of an unknown solution. The pH meter is not necessarily the most accurate method of calculating pH, but it works well enough for a general chemistry 2 laboratory. The bulb of the pH meter is highly sensitive and easy to break, so it's important not to smash it against the glass of the beaker. We calibrated the pH meter 3 to 4 times throughout this experiment in order to get the most accurate reading, as the calibration sometimes went off on the LabQuest. After calibrating the pH meter, Sarah and I guide Logan through measuring the pH of the unknown solution. This unknown solution is after the buffer that we made was broken. So it read around 1.9.
At the very bottom is the pH meter reading.
After finishing using the pH meter, it is important to wash it off with distilled water over the waste beaker and screw it back in to the cup. Voila! Here, Sarah demonstrates the cleaning process as well. That's pH meter calibration for you.